Let's walk through the setup of Evilginx2 to configure a phishing campaign using GitHub as the target. I'll be demonstrating how to configure the proxy server step by step. First, we begin in the terminal, where we launch Evilginx2 by running the command to start the server. With Evilginx2 running, we'll configure the domain and load the necessary fishlets. We need to configure the domain for the phishing site. Here, I'm setting the domain to hacksomething2.com. This is the domain that will be used to trick victims into thinking they are visiting a legitimate site, in this case a lookalike version of GitHub. Since we're running in developer mode, I'm setting the IP address to localhost, meaning the phishing site will only be available locally on this system for testing purposes. By running this command, I'm telling Evilginx2 to serve the GitHub phishing page whenever someone visits hacksomething2.com. Next, we need to fetch the necessary host names for the GitHub fishlet. These host names correspond to different parts of GitHub's infrastructure that Evilginx needs to correctly mimic. By adding these hosts to our hosts file, we ensure that the system directs traffic to our local Evilginx proxy server, avoiding the need to query external DNS servers. Finally, I enable the GitHub fishlet. This activates our phishing setup, meaning that Evilginx is now ready to serve the fake GitHub page at the domain we configured. We can now generate the phishing URL from Evilginx. This URL will lead to the phishing page we will use to capture credentials. At this point, the phishing website is not trusted due to the use of a self-signed certificate. In order to be able to locally open our phishing links in a web browser using a TLS connection signed by a self-signed TLS certificate generated by Evilginx, we need to add Evilginx Root Certification Authority certificate into our Trusted Root Certificate storage. The generated root CA certificate can be found at this path. We need to run Evilginx at least once to generate the certificate file. We need to manually trust the certificate by adding it to the browser settings. First, let's open Firefox settings. Next, look for the certificate subsections and click on View Certificates to open the certificate manager. We need to import the self-signed certificate that Evilginx generated. After that, click OK to save the changes and close the certificate manager. The certificate is now trusted by Firefox, and refresh the page. As you can see, the warning is gone, and the site loads as if it were completely legitimate. Now we need to set up GoPhish to manage the phishing campaign. Let's begin by launching GoPhish from the terminal. You can see the server is up and running, listening on the ports 3333 for the admin panel and 80 for phishing campaigns. Now that GoPhish is up, let's move to the browser and access the web interface. Firstly, we need to configure a sending profile. We're going to define the email server details that the GoPhish will use to send phishing emails. We need to fill out the SMTP server details. The SMTP server is responsible for sending emails. For this demo, I'll use Gmail SMTP server, but in a real-world scenario, you could use your own organization's mail or a server which you have control on, so you'll also be able to spoof sender email addresses. Since Gmail requires a more secure way of logging in than just a standard password, we need to generate an app password. This allows third-party apps like GoPhish to access your Gmail account without using your main password. Go to your Google account. In the app password section, you can name the app you need the password for, and Google will generate one. We'll go back to GoPhish and enter our Gmail address as username and pass the app password in the password field. Before we proceed, let's test the connection. We can use GoPhish's send test email feature to make sure everything is set up correctly. I will send a test email to myself, and if all the settings are correct, we'll get a confirmation that the email was sent successfully. Once the test is successful, I'll save the profile by clicking Save Profile. Now that we've configured the sending profile, let's move on to setting up the landing page. For this demo, we'll use a basic landing page, which is essentially a blank HTML page with a simple script tag. This script will immediately redirect the user to the Evilginx server, where we capture the credentials. The landing page will point to the GoPhish listener, so we can log events such as when the email is clicked or when the victim opens the phishing link. Then the victim will be redirected to the Evilginx proxy. Now let's create the phishing email template. To do that, we will go to the email template section and click new template. For this demo, I've already prepared the content of the email in a text file saved on my PC. Instead of writing it from scratch, I'll simply copy and paste the content into the email body. As you can see, the mail includes placeholders for personalization, such as the recipient's name. GoPhish allows us to dynamically insert this information from the target list, making the email appear more legitimate. Now let's create our target group. GoPhish allows us to easily import a list of email addresses from a CSV file, making it simple to scale up phishing campaigns. For this demo, however, I'll be using just one email address to keep things simple. I'll manually enter the mail details in the proper forms. Now that we have our email template, target group, and landing page ready, let's set up the phishing campaign. Since we're running this locally, I'll set the URL to the GoPhish listener running on my machine. This URL will appear in the email as the link the victim will click on, and it will redirect them to our Evilginx server through the landing page we set up previously. Once everything is set, I'll schedule the campaign to start immediately and click Launch Campaign. Logging into my Gmail account, we can find a phishing email that was just sent. Let's go ahead and open the email to simulate a victim interacting with it. Let's return to the GoPhish dashboard and check the updated campaign status. As you can see, the mail opened and the link clicked events have been logged as expected. Now I'm gonna show how a phishing attack with Evilginx can capture both credentials and session cookies. After entering the credentials, the victim is prompted for multi-factor authentication, just like they would be on the real site. I'll enter the multi-factor authentication code as required, but behind the scenes, Evilginx is not only capturing the login credentials, but also a session cookie that's generated once a victim successfully logs in. Let's switch over to the Evilginx terminal to view the session data. Here, you can see the credential we captured, the username, password, and more importantly, the session cookie. This cookie allows us to impersonate the victim without needing to enter the username, password, or MFA again. Now, let's open a private browser window. I'll navigate to the real GitHub login page, but instead of entering any credentials, I'll manually inject the session cookie that we captured using Evilginx. This is done by using a simple browser extension to edit cookies. Once the session cookie is in place, I'll refresh the page. As you can see, I'm now logged into the victim's GitHub account, completely bypassing both the login credential and multi-factor authentication. This phishing attack demonstrates the serious risk of man-in-the-middle attacks using Evilginx. Even though MFA adds an additional layer of security, attackers can still bypass it by stealing the session cookies, gaining full access to accounts without needing to re-enter credential or authentication codes.